Hello everybody, I'm Emre Koçyiğit and I'm a doctoral researcher in the University of Luxembourg. In this video I want to explain how can you use machine learning to solve classification problems. I prepared a notebook for you, Jupyter notebook, and in each step I will try to highlight the important parts. I will give some tips. Also, to reach this notebook you can check the description. I will add the link. And let's start. So the first step is always understanding the problem. It is very critical, usually it's underestimated, but this is the most important step. So understanding the problem will shape your next steps. Therefore, this is very important. And you should ask a lot of questions at this step. What is the problem? You should be able to clearly define the problem with a few sentences. It should be clear in your mind. What are the metrics? Which one is the most important one? Why? Is there a traditional way of solving this problem? If yes, check it. Try to understand the solution. Check the results. What are the problems? You should understand them very well. And of course, consulting to the domain expert is important. If you have this opportunity, ask questions. What can be the potential challenges? Which features can be more important, more useful? And of course, search similar problems and projects. You can use Google Scholar, okay? Just type the keywords and check the other similar studies. What are the challenges and limitations? What are the performance scores of those models? And check their solutions, especially if they provided their source code, check their source code, okay? They will be helpful for you. After that, of course, the second step will be exploring the data. There can be more steps and other steps, but in this notebook, I'm trying to give you the major ones. Sometimes you can collect the data, or sometimes your colleagues, other departments can share some data, but usually it will not be structured and labeled data set. Usually they will send you some Excel file, some PDFs, and you need to clean and prepare, remove the useless information, and you should increase the quality of the data. And you should read the description of the data set. You can find open and publicly available data sets on kaggle.com. You should read their descriptions, okay? If there is any limitation, what are the representations of the features, what are the values, etc. Then, of course, the first step in this notebook will be importing the necessary packages. We will use pandas and numpy for the data analysis, data manipulation purposes, and this matplotlib and seaborn for data visualization. Okay, let's run them. And then we have a CSV file. I will share also this file with you, hard CSV file. This is publicly available. I will share the source. And by using pandas read CSV method, you can directly load this CSV and create a new data frame. And then we can use pandas methods to understand, to check the data set. Okay, so we can check the first 10 columns, and here you can see we have some columns and we have the features actually, and output will be our target column, labeled column. In other words, the first features will be our independent variables, they will be our features, and we will use them to predict the output. And this is a classification problem, okay? We will use this information to detect positive or negative classes. So output can take 1 or 0. From this display you can have some rough idea. For example, you can see we have all numerical values. Also they are not scaled, right? We have different values, they are not in the same range. And you can see that we have 13 features here, one target column. We don't have too many features. And also from these first 10 rows you can see the output values are all 1. Probably this is ordered according to output. We should shuffle it, we shouldn't use this form. But and here we don't see any missing values, but we cannot be sure about by just checking ahead. We should inspect more. And you can use info method of data frame. And you can see here we have 303 entries, and for each column you can see we have 303 non-null. That means we don't have any missing value And you can also check their data types. We have all integers, only one float, and they are all numerical. So from this information, we can see that we don't have to convert any categorical data to numerical data because we all have these numerical values. And we can check statistical information with this describe method. You can just use the original form, or you can just check its transpose. Okay, I like this form. This is better to read. Here you can see the features and some statistical information. What is the mean value? What is the standard deviation, minimum, maximum values? This is helpful because you can see some problems, or you can have some idea about potential outliers here. Check the minimum value and maximum value. You can understand the distribution. For example, for the age, we have 29 for the minimum, 77 for the maximum, and the mean is 54. You can check the mean value and standard deviation, and for example, if you have bigger standard deviation than mean value, that means there are some outliers for that feature. This information is good to have some idea before the exploratory data analysis phase and before the feature engineering. And also from your domain knowledge, if you see any problem, maybe for the CP value, if you think that you should have more as the maximum value, then you can check your data set and you can enhance your data set. Okay, then after this, we can check the missing values also with other methods. We already checked here, we compared these numbers, but when you have missing values, calculating the difference and understanding which one is more missing is not easy. So we can just use this method, data frame, is null, and some of the is nulls. Okay, so if you just type is null, you can see we will have some false and true values. Of course, this is not very good to read it, but you can just check the sum to see that, okay, we don't have any missing values. If you see here, let's say that for the cholesterol, if you have too many missing values, and if you have big data, sufficient data, you can remove them. You can remove the rows which have the missing values. But if you have small data like this one, we have only 303 samples, you should be careful. You can consider the filling the blanks. And the filling process should be performed carefully, because if you have weight and height, for example, as a feature, you should consider the gender when you are filling the weight or height, because there can be some important relationship between the features, right? So you cannot only use one feature, one column, and you cannot write mean of that column to the blank parts. But you can also consider the gender, and then you can just check the boy, for example, or male, and their weight or height. Then you can get the mean and you can fill the blanks with that. This is one strategy. There are different strategies, but here we don't need. And this is a classification problem. Of course, we should check the class distribution. This is very important because we know that if you have imbalanced class distribution, it will affect the model's performance, especially if one is not sufficient, then model cannot make good predictions for that class. Okay, I'm using the output because output is our target column, right? With this value counts, you can get the unique values and their numbers. With this normalized true, then instead of counts, you will have these floating points, 0.54 and 0.45. So as you see here, total will be 1 because of this, but if you remove this, you can just see the numbers, okay? But with the normalize, you can just check also their distributions. So 54% of the classes belong to class 1 and the others belong to class 0. So distribution is balanced here, but also sometimes you can see 40 to 60. We cannot directly say 40 to 60 or 30 to 70 is imbalanced. To give the final decision, you should check the model's performance, because sometimes that distribution can be enough for the model, because maybe the minority class with the 30% distribution of that class, model can learn everything about that class. It's maybe simple and sufficient. But if you see something like 5 to 95, 1 to 99, of course this is too imbalanced, and usually you should increase the minority. But here we don't have any problem. And then you can of course visualize it to see better. You can have different visualization options. For example, you can use this vertical bars, and here you can see class 0 and class 1, and we have a balanced distribution. Not perfectly balanced, 50-50, but acceptable. Okay, in this step we can explore more and we can check if we have some outliers or if we have some other problems. So our target column is the output column, and we can create features, and to do that we can firstly use def columns. This will return all columns, but we don't want to have target column here, so we can say that difference the target column, the output, and then convert it to array. So this feature now will be an array. Also we have some categorical features as an array. As you see here, these are all categorical features. And with this list comprehension, we can create non-categorical features. Here, the feature for feature in features, for all features, if the feature not in this categorical feature, that means that will be a part of non-categorical features. Okay, then with this print, we can just have some overall idea. These are the all features. These are the non-categorical features. We have here 5, and these are the categorical features. Be careful when I say categorical, their values are not objects, not categories, not true, false, medium, small, large, but numerical values. But the feature is categorical. You will understand it when you see. Now, let's create some visuals. First of all, I created the target variable using this output. Then I have non-categorical features and the target, and I will use pair plot of Seaborn to visualize and to see the relationship between the variables. As you see here, now we have different visuals, and you can see we have age, call, old peak, and also other features. Okay, and here you can see again this is a matrix form, right? And here in each plot we have two different colors because we have two classes. This is a binary classification problem. Orange represents one class and blue represents one class. Output legend is here. Blue represents 0 and orange represents 1. And in this diagram, it seems that our individual features are not very strong or very distinguishing. But of course, all together, we can benefit from them to make the classifications. These ones are very similar, but also here you can see that we have for this old peak, we have a lot of orange, we have a lot of positive class in the left side. So these will be helpful for us to make the classification. In general, also you can see that, for example, with these two features, it is very hard to distinguish these two classes, right? But when you use these two features, we can see that in the bottom side we have more blue, in the left corner we have a lot of orange. Still, it's not very easy to draw a decision boundary, but at least comparing to this one, we can see that with these two features probably we can have better classifications. Also, you can see some potential outliers here. For only looking at these two features is not easy, but you can see that most of the data points are here, but we have some data points also in the right side. But therefore, we should inspect more. Let's look at also categorical features. These were all numerical features. And if you look at categorical features and we will use box plot, it is the best way to see the outliers. You can see we have age, call, old peak, etc. And these diamonds represents the outliers. Okay, as you see here, we have some outliers, not too much, but we should be careful about that. I will not go to details too much, but I will just show one example. Here you can set some thresholds. For example, for the old peak, you can say 4 is my threshold, and I will check these 4 points. Or for others, we can set different thresholds. Here I set some thresholds for these 4 features, and I will print it. All of them, as you see here, I have only 4 for the cholesterol, 5 for the old peak, 1 and 2. So in total, as you see here, I have 12 data points, which can be a potential outliers. Still, it's early to say they are all outliers, but we should check it. If they are maybe typo, then we should remove it. Okay. But if we check them one by one, we can just run these 4 cells. I don't see any problem. I don't see some exception or inconsistency. Okay. Also for others, I don't see any problem. But the only thing that when I check their output, the classes, it seems that we have more 0 than 1. And then I check the 0 and 1, and we have 9 0 and 3 1. That can affect the model, not too much, but still remember we only have 303 samples. So when you remove some data, you should also check the class distribution. If you change the class distribution too much, you can also change the model's performance. Okay, now let's look at another visual, and here you can see we have different colors for each one. For example, if you look at this feature, you can see we have nearly 150 0 and 150 again 1, but for this category, for 2, we have only 4 samples. We should check it. Maybe these are wrong or these are exceptions, outliers, we don't know. Also here you can see, if you look at this feature, we have a lot of 2 and 3 as value, 1 not too much but still acceptable. But if you look at 0, you can see we have only 2 0. So we should check it. Okay, you can check also others, but I checked that, and as you see here, we have 4 and 2, and let's look at them. And again, maybe domain experts can see some problem here, but I don't see any problem. But when I check the output again, we have both classes 1 and 0, but more 0. Okay. In total, if you consider all of them as outliers, then you will have 18 outliers, but still this is early to say that. You should inspect more, okay? But in this notebook, I just want to show the difference between these outliers and without outliers. How can we have different scores, okay? Also, you can decide that, okay, maybe these are not outliers, but they are helpful for me. And now let's look at with the processing and preparing data. First of all, we should create our X and Y. So we should drop the output from our data frame to create X, right? X will be our features and Y will be the output target. If you look at X, here we have the features, we don't have output, but in the Y we have just one vector, right? This is capitalized X. In mathematical notation, the matrices are represented by capitalized letter, but if it is a vector like the Y, we can use lowercase, okay? Okay, first of all, split our data into test and train. Okay, then you can see the shapes, and now we can scale them. Okay, now let's check the X train. And as you see here, now we have scaled numbers. Also, if you look at X test, yeah, we have also again here scaled. So you should be careful here. You should use your training data to fit and transform, but for testing, you should only use transform, okay? Otherwise, there can be data leakage problem. Okay, now let's build our models. We have now, first model will be artificial neural network, multi-layer perceptron, okay? And we imported this from scikit-learn neural network. Then we have hidden layer sizes. These are the number of neurons, okay? I will not go details of the algorithms, but we will build some classification algorithms, and we will make some predictions and check the results. Then we will select the best classification model for us. Here with this fit method, we are also training this model. First one is just building the structure of the classifier. Then here you are using training data to train the model. Now the model is trained, then you can make the predictions. You should import these metrics from scikit-learn metrics. We will use the accuracy, recall, precision, and confusion metrics. And you can make the predictions with this predict method. You should give the test data. Okay. And now with this method, we have predicted values. You can use these predicted values as inputs for this confusion matrix and other metrics. Here, this one is the label, actual values, but this one is the predicted values. We will compare them and we will find the performance of the model. Here you can see the confusion matrix, the 16 and 33. These are the correct classifications. 0 and 12, these are the false classifications. And we can check the accuracy, recall, and precision. And as you see here, recall value is 1, accuracy 80, and the precision is 73. So here we didn't remove the outliers, but now we will remove the outliers and then we will check the results. Okay. First, we will create a copy of data frame as df2 because we don't want to change the original one. If you use only this form, then when you change the df2, the original df will be changed too. Okay, therefore we are not using the original one, but we are using a copy of them. Then, according to our previous experiments, we decided to remove some of them, not all of them. Okay, only the 3 one. You can also remove others, or you can, set different thresholds. Again, let's check the class distribution. After removing outliers, we didn't change too much. Still, we have 55 to 44, same. And if you look at the data, here you can see we have features and output. Now you can create your X and Y like the previous one. Drop the output. Then apply scalar. Okay, fit and transform. But this part should be after the train and split. Okay. So first of all, let's run this part. Train and test split. Then here we can just apply scaling, fit and transform. Not whole entire data, but the train. Okay. Train 2 and test 2 equals scalar transform test 2. Okay. Let's run this. And then we can make the predictions. Here you can see now we have 9 and 3, in total 12 misclassifications. In the previous one we have 12, but not in the same. We didn't change too much, right? Okay, now as you see we have this accuracy, recall, and precision. If you just compare it with the previous one, we don't have better results, so that means they will not affect the model's performance in a good way, right? Removing the outliers. Probably they are not outliers and they can be helpful for us. Now let's build different models and compare the results. Here the first one will be the support vector machine after this multi-layer perceptron. Just import support vector machine classifier from sklearn svm. The structure will be same. I will not go to the details of the hyperparameters, but mostly I will try to use the default models. First instantiate the models, then train the models with this fit method and training data, and make the predictions and use confusion matrix and other metrics to see the results. Okay, here again in total we have 12 misclassifications, and we have slightly better results than the previous one, but not good in general, not better in general. If you look at the SVM without outliers, now we have worse results also in SVM2. We can use XGBoost. You should first install XGBoost. I already installed it, therefore I will not run this command, but if you are using Conda environment, you should write Conda install XGBoost, and then you should import it. And again, you can just create a simple XGBoost classifier. You can train it, and then you can make the predictions. Here we have better results than the previous one, not too much difference, but 11 misclassifications and slightly good results. By the way, I didn't mention that in this project we are trying to predict the outputs, right? Outputs can be 1 and 0, and this is about heart attacks, and the most important class is 1 for us. That means we need to predict the ones better. Our priority will be detecting the class 1, so we shouldn't miss that, because if somebody is positive And if we classify it as negative, that is the worst case. But if somebody is negative and if we classify as positive, this is not good, but still comparing to the previous one, that can be acceptable. Therefore, our most important metric will be recall value. Okay, let's go with the random forest. And again, we are creating and training the model, making some predictions. And here we have also good results, like the previous one. And then I want to choose the random forest model, okay? But of course, you can build more models. You can try to apply a hyperparameter optimization. But in this notebook, I will not go to the details of that part. I think you got the point. You should build the models, compare the models, and then you should select one of them. After hyperparameter optimization, you can build your final model. At this point, you can use pipeline. I will show you how can you do it. First of all, you should import it from scikit-learn. Import this pipeline. Then inside this pipeline, instead of manual steps, you can firstly specify the steps. Then you can use that pipeline. It will be more user-friendly. Also, in the next step, when you save the model, you will not have to repeat the same steps manually. Let's look at here. First of all, we should use scaling. Then we should build random classifier. So this will be two major steps inside the pipeline. We are constructing this here. And I want to hold out some samples from the dataset to test my model. Therefore, for each class, for class 1 and class 0, randomly I choose two samples. So I have positive samples and negative samples. Therefore, in total, I have 4 samples. Of course, I need to drop the output from these samples because I will make predictions with them. This is my samples variable. And here, these are my indexes. I will drop them from my training data. Otherwise, it will be a data leakage, but I will drop to prevent it. So I'm creating another copy, the F3, and just drop these samples from this data set. This is my X and Y. Then use the pipeline and use entire data, not only train and test, now entire data to train the model, final model. Training is completed. I can now make the predictions. I will use the samples, predicted values 1, 1, 1, and 0, and I can create a new column with this one. And then here you can see for this one, that is the actual output. This is my predictions. These are correct, and this row is wrong, right? Actual one is 0, but my prediction is 1, and that one is 0. Okay, then last step will be the saving the model. So how can you save? It's very easy. You can import joblib. Then with this joblib, you can dump the pipeline model. You can give name, heart attack detector, and the format it should be this pkl. Okay, then when you run this, you will see in the directory you will have this file, this model. In the same notebook or in other notebooks, you can load this by again from joblib load method. When you load this model, now you have the model. You don't need to start from the scratch. You don't need to train it. It's already trained. So you can use this loaded model to make the predictions. Here I created a new sample, and then I will use this new sample to make the predictions. And I make the prediction, as you see here, and my prediction is 1. So you can save the model with this dump in the pkl format, then you can load it and you can use it. Okay guys, that's all. Thank you for the watching. I hope it is helpful for you. This is not an advanced notebook. I tried to highlight the important parts. If you have any suggestions, you can write on the comments and I can prepare some more advanced notebooks for you. Thank you for the watching and see you in the next videos.